Hello students, welcome to Nobility Learning Center. Today I will present you about the combined gas law, chemistry grade 9, unit 5, part 7 for our discussion. A sample of a gas often undergoes changes in temperature, pressure, and volume. When this happens, the three variables must be dealt with at the same time. Boyle's law, Charles' law can be combined to give one expression called what the combined gas law. The combined gas law expresses the relationship between what the three variables, pressure, volume, and temperature, at a fixed amount of what gas. How can we derive the combined gas law? The combined gas law is derived from Boyle's law and Charles' law. According to Boyle's law, volume is directly volume is inversely proportional to pressure. According to Charles' law, volume is directly proportional to temperature. When we combine these two uh, laws, we obtain what? Volume directly proportional to temperature and inversely proportional to pressure, and volume equals to a constant K multiplied by what? T divided by the pressure. And the formula of the combined gas law can be derived as what? P1 V1 over T1 is equal to what? Constant K, and P2 V2 over T2 also equals to what? K. P2 V3 over T3, P3 V3 over T3 also equals to what? K. And this implies P1 V1 over T1 is equals to P2 V2 over T2. This is the equation for the combined gas law. Examples about the combined gas law: a 2.00 liter of a gas is collected at 25 degrees Celsius and a pressure of 745 millimeter of mercury. What is the volume at standard temperature and pressure? Okay, here the three variables, temperature and pressure and volume, are what? Uh, varies. Okay, number one, you have to recognize that 5 of the 6 possible values are given in the problem. Okay, we have what? 6 uh, possible values: v1, q1, t1. Okay, example number one: a 2.00 liter of a gas is collected at 25 degrees Celsius and 745 millimeter of mercury. What is the value at standard temperature and pressure? You have to recognize that 5 values are given from the 6 possible values in the problem. Okay, and the 6 is an x. We represented the 6 value as what? X. Write a solution matrix just like this one: p1 v1 p1, p2 p2, and t2. Then the right hand side filled in with the standard temperature and pressure values. Okay, p2, v2, and t2 are filled with the standard temperature and pressure values. We have standard pressure 760 millimeter of mercury, and V2 is required, represented by X, and T2 is 273 Kelvin. Then the solution matrix completely filled in as part Q1 is 745 millimeter of mercury, V1 is 2 liter, and T1 is 298 Kelvin. Okay, the Celsius scale is converted into Kelvin scale during calculations. Okay, write the combined gas law equation, which is P1 V1 over T1, which equals to P2 V2 over T2. Solve for V2 by first crisscross multiplying by crisscross, and then what we obtain Q1 V1 T2 equals to P2 V2 T1. Then divide both sides by P2 T1, and we obtain the formula V2 equals to P1 V1 T2 over P2 T1. The next step, insert the 5 values in their proper place on the right hand side of the above equation, okay, and carry out the necessary operations. We have 745 millimeter of mercury multiplied by 2 liter multiplied by 273 Kelvin divided by 760 millimeter of mercury multiplied by 298, and you will obtain 1.769 liter. The second example, example number 2, the pressure of 8.40 liter of nitrogen gas in a flexible container is decreased to 1/2 its original pressure, and its absolute temperature is increased to double the original temperatures. What is the new volume? Solution: this is a combined gas law problem since you have 3 variables changing that are what? Pressure, temperature, and volume. There will be 6 quantities. Okay, there will be how many quantities? 6 quantities: P1, V1, P1, P2, V2, and T2. The second step, right? Then rearrange the combined gas law and give us what? P1 V1 over T1 equals to P2 V2 over T2, and V2 is P1 V1 T2 divided by T1 P2. Substitute into the rearranged gas law, then V2 is P1 times 8.40 liter times 2 T1 divided by T1 P1 times what? 2. And this gives V2 is 4 times 8.40 liter, which equals 33.6 liter. Another way to solve this is to assign placeholder values that fit the requirements of the possible as follows, okay? P1 equals to 2 times P2, which equals to what? 1. V1 is 8.40 liter. P1 is 1 times T2 equals T2. V2 is X. Substitute into the rearranged gas law, and then you will obtain the same result, which equals 33.8 liter. The third example, the pressure of a gas is reduced to 75% of its initial value, and the volume is increased by 40% of its initial value. Find the temperature, given that the initial temperature was minus 10 degrees Celsius. Solution: let's assign P1 is 1, therefore P2 is 0.75, and let's assign V1 is 1, therefore V2 is 1.4. I will not bother with units on P or V. Your teacher may want the units added in, so I will do that. T1 is minus 10 degrees Celsius plus 273 Kelvin. This gives 263 Kelvin. T1 V1 over T1 is equal to T2 V2 over T2. Then 1 atmosphere multiplied by what? 1 liter divided by 263 Kelvin. This is equal to 0.75 atmosphere multiplied by 1.4 liter divided by 1 X. And X equals to 276.15 Kelvin or 3.15 degrees Celsius. Example number 4, if the volume of an ideal gas is doubled while its temperature is quadrupled, does the pressure A remain the same, B decrease by a factor of 2, C decrease by a factor of 4, D increase by a factor of 2, or E increase by a factor of 4? Solution: write the combined gas law equation, which is P1 G1 over T1, which equals to P2 B2 over T2. I will assign a value of 1 to V1 and allow it to double, okay? I will assign a value of 1 to T1 and allow its value to a quadruple. And then P1 multiplied by 1 divided by what? 1, which equals to P2 multiplied by 2 divided by 4. And P1 is equal to P2 over 2. 2P1 is P2. The answer is D, increased by a factor of what? 2. Okay, this is all about the combined gas law. Thank you for watching. See you later. Bye-bye.